Is it okay? Okay. So again, I think that for this one, I have to draw it again then. So this is my system of coordinates. So first will be, this is my first, second, third, and fourth. So for this is my reference point always, and when it travels from this point to this, it will travel 90 degree. For second, it will travel from this point to this point. So this will be my 180 degree. Okay. So for my case, it is for a part, my system will travel or the phase difference, it is equals to 210. So it will be travel to 30 degree more. So from 280, so it will travel to 30 degree more, that it will be completed that 210 degree C. So I will draw a line. This is basically what, this is basically 30 degree from this point. So the angle or the phase shift is for this equals to 30 degree. Now the second part is my amplitude. As here from this point, when I joined here, so this is my positive x-axis and this is my negative. So this value of amplitude is -2. So this is the phase diagram for my A part. That is this one, that A V of t equals to minus, sorry, I have to cross it. So V of t equals to what? V of t equals to minus 110 cos 2 pi 60 t plus 210. 210 will be my phase shift. So I will write as that V equals to 110. 110 is my amplitude. Having angle, this is my angle sine. Angle sine equals to what? 30 degree. Okay. Is it clear? Then is it clear?
Yes.
Okay, okay. Now moving towards my second part, my B part. So I have to remove it. Now for second part. So firstly, I will make a coordinate. So this coordinate will be this part. So here it is 0. As my value of amplitude is minus 110. So minus 10 will be minus, will my value will lie here on my number line. So this will be minus 110. Now the second will be, we have to move 60 degree. So 60 degree will be 0 to this one. So here it is 60 degree, but my value will be, my value will always lie in second quadrant because my amplitude value is negative. So it will travel to, so I have to travel, or I have to make a reference from this point to this point. So here it is 60. Now this yellow part in first quadrant is 30 degree and this part is 90 degree. So for this system, my shift is lag. So there's a lagging in my system, and lagging of what? 90 plus 30. So this theta will be equals to 120 degree, or this is basically known as the phase shift of 120 degree or phase lag of 120 degree. So the answer for my part B is, will be like amplitude is 110 and the angle will be 120 degree. 120 degree B. Okay, so this is the part number B. Okay, for part C, this is part C. Part C value is this one. Okay. As my my amplitude value is what? Amplitude value is 220. So first I have to draw here again the Cartesian coordinate. So firstly, my amplitude value is positive, so it will lie in first quadrant. Okay, so here let's suppose here it is the value of 2 220, positive 220. Then there is theta which is given to is 30 degrees C. So here it is, I have to travel from this point to this point. So this will be show that here it is 30 and there must be a lag of what? This is basically the lag. So as the angle is 30 degree, so remaining angle will be 60 degree. So this 60 degree will be shown as my lag for this system. So as there is a lag, so this lag will be written as negative value. So negative 60 degree is my lag. So for this system, this is 60, sorry, 60. So it will be written as my amplitude value is 220, 220, having angle equals to negative of 60 degree, and then the value of voltage V. This is the part number C. Moving towards part number D. This is the part number D. So again for this, it is equals to minus 220 and 220 sine 2 pi 50t 50t minus 120. So these are basically the complete value of my part number D. So again for part number D, we will start from the value of amplitude. So my value of amplitude is, so so my amplitude value is what? So my amplitude value for this system is 220. And the second thing given is 120. So 120 means that there is this value lies in my second quadrant. So there must be a phase shift of 30 degree. So this phase shift is basically lagging, so it will be negative 30 degree. For part number E again, it is 15 sine 2 pi 60t minus 60. So it will be 15 is my amplitude. So it will be 15. And then the value that is minus 60. So minus 60 will be what? It will be lies in my second. So it will be 90 plus 60. So it will be 90 plus 60 will be my 150 value. So 150 lags. So it will be also written as minus 150. So 15 angle minus 150. Moving towards my part number F. So also my part number F is minus 20 sine 2 pi 60t plus 120 degree. So first value is again my amplitude value as I do first values. So this 20 equals to the value of amplitude, and then a 120. So 120 basically is the phase shift of my system, where the value having the lag of 60 degree in the first quadrant, and 90 degree in the third quadrant. So 60 and 90 will be my 150. So this will be written as lag. So lag will be written as minus 150 degree. So 20 is my amplitude, and lastly the value of my uh, angle or the phase shift. So again, summarizing this part, that my phasor that my phasor depends on two things. First is my amplitude. Amplitude. So it will be written as amplitude So for amplitude, my value, this value is my amplitude for A, C, E, B, D, and F. And the second value is my phase value, phase shift value, phase shift value. So phase shift value will be whether it is phase in, phase in, and phase out, phase in and phase out. Phase in is always my positive value, and phase out is my negative value. So phase out value also known as lag in my phase or phase lagging. So this is the complete solution of example 9.4 A part A from part F. Okay, moving towards the next. This is my 9.5. So, okay, yes. Now in this case, V equals to this one, V equals to 110 and angle of 120. So it will be as I described earlier. The first value is my amplitude value, and second value is my phase value, which is written as theta. So the general form is my V, and with respect to time t, and this will be written as A cos 2 pi omega t plus theta into the value of V. So uh, this is the value. Now I am doing the solution for part number A. So part number A, I have given that V value equals to what? Sorry, V value complete, but for V there are two parts. So A equals to what? A equals to 110. So A equals to 110, and phase difference equals to 120. So this will be equals to that Vt, that my velocity which changes with time, also known as my instantaneous velocity. Now A value is 110. So putting here, so it will be 110 cos 2 pi omega t plus theta. So theta will be 120 degree with the value V. So this is the solution of part number A. Now moving towards part number B. So part number B will be my part number B. B will be my V equals to 120 with angle equals to minus 30 degree. So this will be written as V of t equals to the value of amplitude. The amplitude value is 120, so it will be 120 cos 2 pi cos 2 pi cos 2 pi. So it will be like, I have to elaborate it. So cos 2 pi 60t. Then there is a negative. So my this will be by default the value is positive always. So, but my value is negative. So you have to put negative 30 into t. Yes. So then negative positive as it is equals to negative. So you have to elaborate that my VT value will be 1 120 cos 2 pi 2 pi 60t minus 30 degree 30 degree into the value of volt, that is V. So this is the complete solution of my part number A and part number B, example 9.5. Okay, now moving towards the next one. Okay, so for the next one, convert the following number in Cartesian components to polar components. So first you have to know what is polar components and what is basically how many how many things basically involved in my polar components. So Zan,
Yes, sir.
what do you know about polar components?
Polar's component has to be like first a VM, then the angle or the phase.
Yes, yes, you're right. Basically, in then in coordinates, there are two things. First is my magnitude, and second is my angle. So, what is basically
Mhm.
magnitude? We have to find the magnitude by using a formula. So, this formula is
Yeah.
always same. Okay.
Pythagorean theorem.
Yes, yes, yes. So, for this A, B, C, D, we have to do the same process. So, just moving towards the first one. So, for first one, we have to find first the magnitude. So my magnitude will be m will be equals to under root. This is the under root value. Let's say first value a equals to uh, a part equals to z equals to 3 plus j4. So 3 is my real part and j basically is my imaginary part and with 4. So we have to take under root value under root and then taking the square of these two values. So taking the square of 3 and the 4. So it will be 3 square plus 4 square plus 4 square. So it will be 3 square is my 9 plus 16 will be 25. So it will be 5. Okay. And then second thing in my polar component is finding the theta. So theta
Tan
equals to,
inverse
yes, tan inverse
y over.
upon x. Y upon x. So it will be tan inverse. What is the value of y? Value of y is, for this case, the polar value, that is my uh, complex part, that is my basically imaginary part having iota or j value is my y value, so it will be equals to 4 upon 3. So from calculator we'll find that tan inverse 4 upon 3 equals to 53.1 53.1 degree. So this will be how to write the answer. So answer first, I have to write the magnitude, that is my 5, which I find here. Then an angle sign with angle what 53.1. So it will be 53.1 degree. So this is the solution of part number A. For part number B, we have do the same, that it will be 4 square plus 9 square, 4 square plus 3 square, that is it, the value is always also 5, and then 3 upon negative 4, So the angle value is 143.13. Now for the third one, it is also 3 square plus 4 square. That will be my 5. But the tan inverse value will be minus 4 upon minus 3. And the value is approximately equals to minus 126 degree. For the last part, it is 4 and this one. So it will be 5. And then tan theta tan inverse equals to minus 3 upon 4. The value is minus 36.8. So it will be written as 5 is having angle minus 36.8. So these are basically, this is the solution of part number A, and the answer, this is for B, this is for C, and this is for D respectively. So this is solution of example 9.6. Now moving towards the next example. Okay, okay. Sorry. So for 9.7, convert the following phases to Cartesian coordinates. So the first, it is V equals to 110 having angle 120 degree. So as I described earlier, there's a formula to convert these two parts. So first thing to know that 120, that is V equals to 120 angle, sorry, V equals to 110 angle 120. So 110, the first value will be my amplitude value, and 120 is my phase value. So again, this is my A value, and this is my 120. 120 is my theta or phase difference or phase occurrence value. So for this, we have to convert this polar system to my Cartesian system. As my formula to convert one system to another, it is basically depend on the amplitude, then a real part and the imaginary part, and then a phase difference and a cause, basically cause of angle. Hmm. So this will be written as, for the part number A. I am writing for part number A. Part number A, it will be written as A cos theta, A cos theta plus J, this is my polar value, J A sin theta. Okay, so this will be written as, what is the value of A value for my first part is 110. So it will be 110 cos theta will be 120. So 110 cos 120 plus J, A value is 110 sin 120. Now calculating the value of cos 120. So cos 120 value equals to, I have to write here at the end. So it will be 110 and cos 120. So cos 120 value equals to minus 0.5 plus J 110 into sine 120. So the sine 120 value equals to under root 3 upon 2. Then I have to multiply this So multiply 110 with minus 0.5. So the answer will be minus 55 plus j. Then I have to multiply 110 with under root 3 upon 2. So this value equals to 95.26. 95.26. This is the method to basically convert my Phasors to Cartesian component. So Cartesian component, there are firstly you have to know that there are two parts. So first part is your real part having no imaginary value, and second is my imaginary part having value I, j, k. So it depends on my polar coordinates. So the next part is part number B. Part number B, it is 240 having angle 240 angle minus 120. So 240 again is the amplitude and 140 is the phase. So how to write it? So for writing, it will be like A is my 110 cos of minus 120 plus j into 110 sine negative 120. So after this, we have to find the values of cos negative 120 and sine negative 120 in calculator. So what is the value of cos negative 120? So cos negative 120 is my negative 0.5. So this value equals to, I have to write here that this value equals to minus 0.5, that is cos minus 120, and sine minus 120 value equals to under root 3 upon 2. So this is the, now that's just then multiplying the value. So the minus 120 and then minus of j 207 is my answer of part number B. So similarly, we can do the part number C and D. For C, this is the C part where A value equals to 480, 480, and my theta value equals to 150, and then just I have to put these value in my formula. Now the last part, D part, will be the value of A equals to 880. So A equals to 880 and theta value equals to minus 60 degree. So in these part, just summarizing all the example 9.4 and sorry 9.7. So to convert my phasors to Cartesian components, so first you have to elaborate two things: the value of A and theta. Then you have to put in your complex number. Complex number must having a real part and imaginary part with a cos of angle. So cos, you have to cos of, let's suppose cos of 120. So then after cos of 120, you can put the value of 120, and then by using calculator finding all these cos and sine values to simplify the numerical. So so this is how we can solve example 9.7. Now 9.8. So 9.8 is represent VT, voltage with respect to time 150 cos 2 pi 60t minus 60 plus 100 sine 2 pi 60t plus 120 degree by single sinusoid. So for single sinusoid, it will be equals to what? First, you have to compare both values. So for this system and for this system, so there are two systems. So you have to counter with your two systems. Okay. So for this system, there are two values. This one and this one. For this, a value equals to 150, and my phase shift theta value equals to minus 60. For second, my a value equals to 100, and my theta value equals to 120. Yes, so it will be equals to 150 angle negative 60. This is the first part, and then taking the sum from the equation plus 100 angle 30. So this is the way to convert two values with respect to basically two functions, function 1 and function 2, to represent a single sinusoid. Yes. Now example 9.9. So for this system, we have to draw the phasor transform circuit. So for phasor transform circuit, which is basically shown in figure 9.31, the AC voltage source is given by 150 cos 2 pi 60t plus 60t. So all these values are given. So for first system, firstly, yes, my first value is Vs. That is my voltage source. So the voltage source given is this one battery, this one. So you have to elaborate this. For this system, this is my A and this is my theta. So you will write that Vs equals to 150, this is the value of amplitude, with the angle 60 degree. Okay, so this is the first part that you have to calibrate the value of Vs, which is given. Now the second value is my impedance value. So impedance value, that is my R1. So R1 equals to what? 55 ohm. Now the third value will be R2, which is also now omega. So how to find omega? As this is for the system right here, As we know that V equals to A cos omega t plus phi. This is general formula for finding the V or current. Is it clear then?
Yes.
So then comparing the value of omega. So this is the value of omega, and here it is the value of omega. That is omega equals to 2 pi 60. So 2 pi 60 is the value of omega. Omega equals to 2 into 3.14 into the value of 60. So for this we have to just find the value from calculator. So this value will be equals to 376.99 double one radian per second. Now the value that is ZL1. Where is the ZL1? Yes. So how to find ZL1? So ZL1 find where J omega L1. So J omega
Yes.
L1. Yes. Hello.
Yes, sir.
So it will be again. It will be equals to uh, Z value basically equals to again. This is the J
JUL.
omega L. Okay, then. So for
Yes.
Z1, it will be equals to J1 omega L1. Okay, so just we have to calibrate or find the value. Is it clear?
Yes, sir.
Okay, so here it is then. So this is the L1 value. So this is the L1 that is 65 mH, and it is L2 that is 210 mH. Micro milli basically milli value is millihenry. This is the value of impedance. So just putting the value in ZL1. So ZL1 will be J omega L1. So J will be my polar value omega, that is 2 pi 60 into L1, that is 60 milli. So milli mean 10 power minus 3.
-3.
Yes. So just finding the value from calculator. Again for the second value, that is
Number
ZL2, that J omega L2. So that then just putting the value of omega and L2. So the value of omega is what? 376.99, and the value of L2 is 210 milli. So milli means 10 power minus 3.
temporal -3.
Yes. Now finding the impedance for capacitor. So for as we know
Capacitor
that
is 1 over
1 over
is
J
1 over
omega
J
C1.
omega C1.
Yes. So just give me 1 second. So
So, sir, we just transform the circuit from normal to phasor.
yes, 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 definitely. You are right. So then it will be 1 upon J
J omega C.
omega C1. So it will be 1 upon J. The value of omega is this one, 376 point. So it will be multiply, and then it will be 3.376.9911. Then take multiply with the value of C1. So C1 value is this one then, which will be given at 35 micro. So what is micro? 10
10
raised,
to the power 6.
yes, 10 raised power minus 6. So after this, we have to calculate using calculator to find the value. The value equals to this one. minus j into 75.7881. So this is for basically capacitor impedance capacitance value for one capacitor one, and for capacitor two will be only one difference, that it will be 1 upon j omega and then only C2, so that I have to compare the value with the value of capacitor, which is which is which is basically C2. So this is for the impedance of my C1 and C2, and then basically this is given in my problem, that is 9.31. So I have to convert this. So first I convert the parameters, that I convert this parameter. Okay, so this parameter into what? The value of amplitude and angle of this one. So it will be Vs with 150 and angle of 60 degree. Okay,
Yes.
then give me 1 second for water, please. Then
Yes, sir.
give me 1 minute, please, for water.
Okay.
Okay, thank
Problem.
you. Okay, okay. Give me one, please. Okay, so this is the first part, that I have to convert my first value, that is my Vs instantaneous value, T value, into a capital Vs, which is my voltage value of my source. And for source, there are two things. First is my amplitude value, and second is my phase value. Okay, this is for voltage source. Now moving towards the next part, that I have to convert. I convert my L1 using formula j omega L1. So this value will be replaced by j j 24.5. This capacitance value is always 1 upon, this is replaced by 1 upon j omega c1. So it will be minus j 75.78. So we have to replace our all values, and then my last parameters are, or my last circuit diagram will be shown like that. And this is my last solved diagram basically, or my polar diagram for this equation. So the first parameter which is changed is this one, this parameter, this parameter, this parameter, and this parameter. Only thing which remains constant is the value of resistance. And this case, the value of R1 and R2. So R1 and R2 remains same for when converting to Cartesian to polar. So this is the complete solution of this example. So this will be like, hmm, so this will be like this. So yes, now 9.10. So 9.10 will be like, draw the phasor circuit for the circuit shown in 9.35. So this is the circuit which is showing in my 9.35. So I have to draw it using, I have to convert into my coordinates value, that is my vs value, zr1, zr2, zl1, zl2. So for this, the first thing is, this is my amplitude value, this is my theta value. There is no theta value, as there is only omega t plus 0. So my phase shift is 0, and its amplitude equals to 200. Then R1 and R2 will be same, and then omega equals to, as we know that this value is known as omega, so it will be equals to 2 pi 60. So 2 multiplied by 3.14 into the value of 60. So this value is 376.9911. So this is the value uh, for the omega, that is my angular velocity. Then for angular velocity, I have to put ZL1. So as the value of ZL1 is J omega L1, so it will be J omega. So putting the value of omega, that is 376.99. The value of L1 is nothing but it is equals to 30 into 10 is power negative 3. Okay, so then computing all the values, we find that the value equals to 11.3097. So this is the value of z having inductor L1. Now the second is my z value for inductor L2. So it is same, it is j omega L2. So it will be j omega value is 376.99, and then the value of L2. So this will be my ZL2. Then my combined value of Z is equals to 4 parameters. So first parameter will be my ZR1. Okay. Then ZR1, then ZR2, then ZL1 and ZL2. So these are the 4 parameters to basically define all 4 parameters. Okay. So for this, the complete value is 150, plus j value is what? J value is 143 point this one, and this will be equals to this one. Now finding the current. So as we know that current equals to Vs upon Z. So Vs equals to 0.9642 into the value of minus 430, this one. So this will be equals to the impedance value, and then the IT, as IT given as 0.9642 into cos of this value. So this is my amplitude value. Again, this is my amplitude value, and this is my negative 443 point. This one is my angle or phase shift value. So VW will be equals to I into ZR1 plus ZL1. So this will be equals to this value, and simultaneously V naught equals to this one. Now VW equals to combining this value, and VW equals to this one, where this value equals to amplitude and this value equals to theta. Again, V naught equals to this value equals to amplitude, and this value equals to theta. So this is the complete solution of example 9.10. Now moving towards the next example. Okay, let's move. Yes, example 9.11. Find the current I1, I2, and I in the circuit below. So as we know that the value, how to find the value of I. So to formula, I equals to V voltage divided by Z, that is my impedance. So first we have to find the value. So first value is my Z1 and Z2, because in current case, current I1, it is Z1. In case of current I2, it will be VZ2. VZ2. So these are the two possible things to communicate that I have to find I1 and I2, and this is how I find I1 and I2. And then how to find I basically I basically equals to,
I1 plus I2.
yes, I1 plus I2.
So at first you find Z1, Z2, and then you compute I1 and I2, then
Yes,
I1.
yes.
I
So for Z1, so major thing is we have to find Z1 and Z2. So what are the formula, or how to find Z1 and Z2? So as the Z basically value is Z value is depend on ZR plus ZL plus ZC, that it depends on the value of impedance of resistance, inductor,
Yes.
and capacitor. So for first case, when there is Z1, okay, so for Z1 there is only resistor and inductor. Oh, is it clear? So the parameter involved will be my, I have to raise this. Okay. Hmm. Hmm. For so parameter that are involved is resistor and inductor. So it will be Z equals to ZR1
ZR1 plus
plus
Z.
ZL.
Yes.
So, and for second, this is for Z1, and for second Z2, so Z2 will
Z2,
be equals to
ZR2
ZR2 plus
plus
Z,
ZC.
ZC. Yes. So from this equation, this formula, we can find the value of Z1 and compute here, and
Yes.
Z2 and compute here, then finding the value of V1, V2, and then again summing both value to find the value of I. That is my total current in my system. Let's move forward. Now 9.12.
Mhm.
Find I, V1, V2, V3, V4, V5 for this system.
It's already, the circuit is already in phasor form, so good.
Yes, yes, yes. So for I basically, how to find I? Basically it is, yes, so 50 into 150, and then divided with my polar values, that is 5 plus 6j.
Because they're all in series, we add them all.
Yes, yes, yes. Then I add them all. Then for V1 it is V equals to IR again. So I value is 1. and V is 5. So for V2 it is polar. So this one, then this one, V1 equals to I is 1 and then 5. So V1 equals to, uh, here we can find the value of I. So I basically equals to what? I equals to this value. So just multiplying these two values for this one. So it will be I into J6. For V3, this will be minus J3 into I. For V4, it will be equals to 10 and it will be 15, sorry, J5 and respectively. So for this, it is the simplest part where just we have to multiply the value of
Yes, yes.
I with R. Is it clear?
Mm-hmm.
Okay, let's
Make
move.
5 V1, V2, V2, V4,
Yes,
V5.
yes, simply, yes, simply. Yes, then this one, 9.13.
This is already transformed, I think.
Yeah.
No,
No, no, no, it is not transformed then. We
no,
have to
not transformed.
transform it. We have to transform. This is the important
Yeah, it's
question.
easy.
It's easy
Easy
now.
to
Yes,
transfer.
yes, yes. So again, we have to just given summary that we have to firstly we have to find the value of Z1, ZL1, ZC1, ZC2, ZL2, and then there's a connection which says that VC is parallel to uh, to what two parameters ZL2 and 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 the resistance 4. So after this we have to find the value of total Z, then I value I equals to V upon Z. So this is the easy question to solve. Is it clear? Any question
Yes.
from? Okay, okay. 9.14 then. Oh, this is the important. Use Y to tell convergence
This is a
inter.
mesh analysis, I think.
Yes, yes. V not in the following equation. So how to find ZA, as there are three terminals then. So
Mhm.
where are these three terminals? This is the terminal A, terminal B, and terminal C. So for Z1, again for Z1, this will be equals to, yes, for this will be equals to ZA multiplied by ZB plus ZB multiplied by ZC plus ZA multiplied by ZC divided by ZC. For Z2, it will be equals to ZA multiplied by ZB plus ZB multiplied by ZC plus ZA multiplied by ZC divided by ZA, and then computing the value. So this is the simplified value. Now the fourth one, Z3 then. Z3 will be ZA multiplied by ZB plus ZB multiplied by ZC and then ZA multiplied by ZC.
Mhm.
So after this, after the complication, just finding the parallel impedances. So Z4 will be equals to what? Z4 equals to Z2, which is parallel to ZE. So just give me 1 second. I have to zoom it. So yes. Now from this point, my Z2 value, Z4 value, sorry, Z4 value shows that my Z2 is parallel to ZE. So where is Z2 and where is ZE? So here it is that this value Z2 and this value, it is shown that both are parallel to each other. and the next one Z5. So Z5 is basically shows that Z3 is parallel to ZD. So here it is the points, and here it is. Z3 is parallel to ZD. And then the last part, which is Z total. So Z total will be equals to Z4 plus Z5 respectively. So taking the sum of 2.796 plus J 0.94 and 2.67 plus J 4.96. So this will be my Z4 and Z5 respectively, and then add them to find the value of ZT. As we know that I equals to V upon S, V upon Z. So Vs will be my voltage value, which is 50 angle 0, with with the value of Z. So Z value will be equals to 5.4765 plus J 5.9572 ohm. So after this, after the division, the value of current, that the value of I is 4.1818 minus J 4.5488 amperes. So this is the value of current. So the value of current is basically V upon Z. Now the next one is my V naught. So V naught basically is at point 0. So it will be Z4I. So Z4 value will be what? Z4 value is this one. So Z naught will be then, like, this is the important thing, that Z naught equals to, or it is Z naught equals to V naught equals to Z4 with the value of I current. So again, V naught equals to Z4 into the value of current. So I have to elaborate here, as the value of Z4 equals to 2.7996 plus J polar value, which will be 0.9726, and then the value of I. So the I value is 4.1818 minus J minus J 4.54 4.5488 88. So after this, we have to multiply Z4 value with I value. So my Z naught value will be equals to V naught value equals to 18.3128 with the angle minus 28.24 degree V. So this is the way, just multiplying the value of Z4 with the value of I. So this is the completion of example 9.14. Okay. So here it is a summary. This summary is very important. So you have to know about all the things which is done in this slide. So first thing is my phasor. Just give me 1 second. Yes. So this is the phasor. So what is phasor, and how basically phasor define different properties. So phasor represents the magnitude, as I described earlier. First thing is magnitude and the phase of sinusoidal. So phasors are useful in finding the voltage and currents in the steady state. Okay, when the input signals are sinusoidals, the ratio of the voltage phasors to the voltage to the current phasor is I is known as impedance, and this value is the function of impedance. Now the third point is the admittance. Admittance is basically Y value is defined as the ratio of current to the voltage. So this is the main summary of my uh, lecture number 9, part number 1. So any question regarding this unit, Zen? Is it
No,
clear
sir.
everything?
Yes.
Okay, okay. Let's move towards the next part. Next part of this. This is my. Just give me 1 second. I think this is the yes. This is the next part.
Sir,
Yes.
what time do we finish?
Uh, within within 5. Uh, how many time left? How much time left?
I don't know actually, sir.
I think I have 10 to 15 minutes more.
Okay, sir.
Okay, so please give me. So I will start this. So this is the simplest. Yes. So again, chapter number 6, chapter number 9, Zen, phasors and impedances, part 2. So Zen, inshallah, I will complete chapter number 9 today. So chapter number 10 and 11 will be proceed after this lecture. Okay. So inshallah, I will it will complete chapter number 9, and then after we complete chapter number 10 and 11. Is it clear?
Okay, sir.
Okay. Then this part of chapter is basically about my series and KCL and KVL. So KCL, again, just for summarizing, the sum of current entering the node equals to sum of currents leaving the node. The algebraic sum of currents leaving the node equals to 0, and the algebraic sum of currents entering a node equals to 0 for KCL. For KVL, the sum of voltage drop across around a loop equals to sum of voltage rises of the same loop. Second part is the algebraic sum of voltage drops around a loop equals to 0, and the algebraic sum of voltage rises around the loop must equals to 0. So these are the major parts of KCL and KVL. Now moving towards my example 9.9.1, we have to find the current. Again, for this we have to find the value of I1, I2, and I. So let's start with the with the question. So first, this is, where is I1, where is I2, and where is I? So for this system, here it is I1, and I1 is the function of R1 and L. For I2, this is the function of R2 and the value of C. And again, the I function will be equals to the value of I1 plus value of I2. Okay. Now, for this, we will start from the same parameter, as we know that the value of I equals to V upon Z. So the I1 value will be equals to V, where V will be my voltage source Vs divided by Z1, and the second value then it is I2. So I2 value will be again V upon Z. So it will be V as divided by Z2. So first we have to find the value of Z1 and Z2 respectively. So for this system, Z1 will be equals to ZR1 plus ZL. So then ZR1 value is 1. The sum of basically ZR1 and ZL equals to 125 plus the value of polar is 180. So this will be equals to 219.1461 with the angle value 55.22, that is 55.2222 degree. Oh, okay then, so this will be my value of Z1. Now for Z2, Z2 it will be equals to Z ZR2 plus ZC. Now, what is the value of the Z2? So as we know that this value equals to ZR2 plus ZC. So the sum of this ZR2 and ZC will be equals to 200 minus J, that's my polar function, with 260, and this value will be equals to 3 I think 328.02 with the angle minus 52.4314 degree ohm. So this is the value of Z1 and Z2 of for my system. So after this, after this we have to find uh, the value of I1 and I2. So the value of I1 and I2 will be I1 equals to Vs divided by Z1. So what the value of Vs is? Vs value is 550 with the angle 120 divided by the value of Z1. So Z1, I find the value, what Z1 value is, I think, oh yes, 219.1461 with the angle 55.2222. So angle will divide with the angle, and real part will be, or impedance value will be divided with the impedance value. So how to find it? So for this system, the value of I1 will be equals to 1.0695 plus J into 2.2705 ampere. So this is the value of I1 for my this system, which is shown in figure 9.39. Now moving towards my I2 value. I2 value equals to I2 value equals to I2 equals to Vs divided by Z2. What the value of Vs is, that is 550 550 with the angle 120 degree, 120 degree, all divided by the value of Z2. Z2 Z2 will be my 328.0244 with the angle minus 52.4314. So again, real part or the value of amplitudes for Vs and Z2 will be divided separately and the angle will separately. After this, we find the value and this value will be equals to 1.6767 with the angle 172.43 degree. So this is the value of Z1 and I1 and I2. So as written in the angular form, so we have to convert into real and polar form, that in a real part and a j part. So for this, yes, we have to, this is my I1, that the value of I1 I found using formula is 2.5097 with the angle 64.778 degree. So this shows that my I1 value will be 1.0695 plus J is 2.2705. So this is my I1 value after converting into real part and a polar part. Now for I2 will be I2 will be I2 will be 1.6767 with the angle 172.43 and this will be I2 equals to negative 1.6621 plus polar value, that is J, and 0.2208. These are my two values of I, that is my I1 and I2. So as this is part number A, just give me 1 second. Yes. So this is my part number A to find I1 and this is my part number B to find I2. Now with using real and polar form, we have to find the value of I. So this is the last part of this numerical. So C will be I equals to I1 plus I2. So I1 value is 1.0695 plus j 2.2705. Then a plus sign with the value of I2. As the value of I2 I find is minus 1.6621 plus j 0.2208. So from the comparison, we have to just give me 1 second to elaborate. So we have to compare real part with the real part and imaginary part with the imaginary part. So this will be uh, 1.0695 and then 1.6621. So from this 1.0695 minus 1.66. Okay, my answer is minus 0.5926 plus j value 2.2705 plus 0.2208. So it will be from calculator, this value is 2.4913. So this is the complete part regarding this to find the value of I, that is equals to I1 plus I2 respectively. Then any question regarding this question?
No, sir.
Is everything clear?
Yes.
Okay. So this is basically impedance formula, the value of finding the value of current, value of voltage, V root mean square, B mean. So we almost, I think, just give me 1 minute. We cover today the complete, I think, 9.11. So we complete almost all the examples of chapter number 9. So this is all about chapter number 9. So this is, I think, enough for chapter number 9. So chapter number 9 is phases and impedances. So the main formula regarding the impedances are basically finding the value of z1 with two parameter, that in this case that z1 equals to ZR1 plus ZL and Z2 equals to. So these are the major thing to remember in the numerical, and all the values to find I, find Z, find V are same for all the numericals. So just little consideration, and inshallah there will be no difficulty regarding these questions. Then
Inshallah.
uh,
Yes, sir.
this is I think this is it for chapter number 9, and this is it for today's lecture. So hopefully you can take more lectures for chapter number 10 and 11, is it?
Maybe I will, yes, sir.
Okay.
Most probably I will, but I will discuss with my parents first.
Okay. So is there anything confusing?
No, sir.
Anything is everything is clear?
Yes, sir.
Okay. So then that's it. So uh, goodbye from today's lecture, and
Thank you so much, sir.
Thank you, and take care.
No problem.
Oh,
You too.
okay then. Allah Hafiz. Assalamu alaikum.